All right, we're back with a continuation of square roots and real numbers. And so we had just finished with looking at square roots of numbers that aren't nice. So we have to guesstimate, we have to zestimate, we have to whatever. We have to estimate those results. I had mentioned that those were called irrational numbers. And so we're going to look at some different types of numbers in this video. The first type of number that we're going to be looking at, you have these ovals on your sheet there, and I gave you a nice big printout for them. You're going to be filling in some of these ovals. So the way we want to think about this is that it's kind of like squares and rectangles. If you've heard it before that a square is a rectangle, but a rectangle is not a square. A square is a rectangle because all you have to be a rectangle are 4 right angles, and a square has that. But to be a square, you have to have 4 right angles and all the sides have to be the same. And a rectangle doesn't always work that way. And so we're looking at what categories can we put things in. We're categorizing things. That all fish are animals, but not all animals are fish. Same type of thing here. So I've got these ovals. I'm going to explain how this works. So I want you to go ahead and start filling these in. Natural numbers, natural numbers. Natural numbers are numbers that occur in nature. And we use this fancy n, for whatever reason, we use this fancy n to show natural numbers. Again, it's the lazy mathematician way of writing natural. Examples of natural numbers, again, are numbers that occur in nature, like 1, there's 1 teacher. 5, there are 5 students. 22, there are 22 sticks. And so natural numbers are whole numbers that are positive. So positive whole numbers, no negative numbers. You don't have -5 zebras. That doesn't make any sense. And so we have positive whole numbers, or are called natural numbers. If you break a stick in half, you have 2 sticks. But counting. And so those natural numbers are your basic set of numbers from 1 to infinity. The next step up are called integers. And we use a fancy z to do integers. And you can fill that in on your notes. Why a z? I don't know. But integers, we use a fancy z for integers. So 0, -1, -22. The integers are all the positive whole numbers and their opposites, and 0. And so all the positive whole numbers, 1, 5, 22, those are all natural numbers. But they're also integers. So everything in the inner circle is also an integer. 22 is a natural number and it's an integer. It fits both criteria. It's a positive whole number or a negative whole number. It works for both. However, a -1 is not a natural number. -1 is not a positive whole number. So it works going out, like the arrows are right there, but not going back in. That does not work. You can't do that. So you can't work back in. So it only works going out. That anything that's in the natural oval is also inside of the integer oval. And that's because a natural number, 1, 5, 22, meets the criteria of being an integer. It's a positive whole number or a negative whole number, or 0. The next set of numbers are what are called rational numbers, and with a Q, fancy Q. Why a fancy Q? I don't know, but it's a fancy Q. And so we've got fancy Q are rational numbers. Rational numbers make sense. A number that makes sense would be, well, I'll even say a rational decision. A rational thing to do would be if you're walking up to a cliff. The rational thing to do is to stop before you jump off. That's the rational decision. A rational number is a number that makes some sense. A fraction, 21/7. You can take 21 things and break it into 7 groups. That's something we can do. And we can do that with physical objects. So it's a rational number. It's a rational thing. And any fraction can be written as a decimal. 21/7 can be written as a decimal. 4.5 is 4 1/2, or 9 halves. And so you could have 9 half sandwiches. I don't know, something like that. And so 4.5 is a rational number. A rational number is any fraction or any decimal that stops or repeats. Because remember, 1/3 could also be written as 0.333333333333 forever, repeating. And so if it can be written as a fraction, it's a rational number. 4.5 can be written as a fraction as 9 halves, and 21 halves, or 21 sevenths, excuse me, is a fraction. So a rational number is any number that can be written as a fraction or a decimal that stops or repeats. Now there are those weird ones, like the square root of 10, square root of 15. Those are decimals that never end. And what we call those, I'll back up even further. Those arrows that I've drawn before, a natural number, 1, 5, 22, those can also be written as fractions. Negative 1 can be written as a fraction. 22 can be written as a fraction. You could write it as 22 over 1, or negative 1 over 1, or negative 22 over 1, or 5 over 1. You can write any whole number as a fraction, which means that every natural number, 1, 5, 22, every natural number is also an integer. And every natural number is also a rational number. So 1, 5, and 22, those three numbers, as well as all the other natural numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, all those natural numbers have three names so far. They're natural numbers, they're integers, and they're rational numbers. They work for all those criteria. Integers, negative 1, negative 22, 0, those three, they work for the integers. You can't call them a natural number, though. You can't go negative 1, that's a natural number. It doesn't work that way. But negative 1 is an integer, and negative 1 is a rational number. You can write it as a fraction. Negative 22 is an integer, and negative 22 is a rational number. It has two names, but not natural. The last distinction that we're going to be using are real numbers. Real numbers are all those numbers that we work with, all the positive whole numbers, all the natural numbers, all the integers, all the negative numbers, all the fractions, all the decimals are real numbers. And we have these irrational numbers over here, which we don't have a fancy letter for. Irrational numbers are their own little subset of numbers. There's an infinite number of them, but there is its own subset of numbers like pi, or the square root of 10, or the square root of 2. Any square root that we don't know how to do is an irrational number. But it is real. It's on the real number line somewhere. We just can't pinpoint it. This is a lot. This is a lot to take in. We got natural numbers, we got integers, we got rational numbers, we got real numbers, irrational numbers, all this vocabulary. But these ovals will help a little bit, because as you work out, natural numbers are also integers, are also rational numbers, are also real numbers. Integers, I'm going to go ahead, I'm going to even draw maybe another line here in purple. Integers are also rational numbers, and they're also real numbers. So they have three names. Rational numbers are also real, but it does not work going into the circle, into those ovals. 21 sevenths is not a natural number, because 21 sevenths is not a positive whole number. Negative 1 is an integer. Negative 1 can be written as a fraction, so it's a rational number. Negative 1 is a real number, but negative 1 is not a positive whole number, so it's not a natural number. And that's where we're looking at, is a square a rectangle, or is a rectangle square? Is a fish an animal, or are all animals fish? We're going to be looking at that kind of logic. It's not arithmetic. It's not adding, subtracting. It's logic. And that can be very difficult, and that can be very hard. But let's look at some examples. So what I'd like you to try, at least try it. Write all the classifications, all the names that apply to each number. So in this box for 18, I want you to write, is it a natural number? Is it an integer? Is it a rational number? Is it an irrational number? Is it a real number? For 8/9, is it a natural number? Is it an integer? What names could you give that number? Go ahead, pause it, try this. Okay, hopefully you at least wrote something down, tried it, put something in there. I'm going to start with 18. 18 is, well, first I'll ask the question, is it a natural number? Is it a positive whole number? Yes, 18 is a positive whole number. And so if I go back, 18 is a natural number. So it's natural. Go back here, is it an integer? Is it a positive whole number or a negative whole number? Yes. It's not negative, I agree, but it's that or word. If it's a natural number, just like this red arrow here shows, it's also an integer. It also meets that qualification. So 18 is also an integer. Because integers are all the positive whole numbers or their opposites. Is it a, wrong direction. Is it a rational number? Could you write it as a fraction? Well, yes. 18, you could write it as 18 over 1. So 18 over 1, 18 is a rational number. And it is a real number as well. Because all the numbers that we're going to be looking at are real. And I promised I would talk about numbers that aren't real, and I'll try to get there, but we'll see how much time we have. 8/9. 8/9, we've got 8/9. Let's go back. Is it a natural number? Is it a positive whole number? No, it is not a positive whole number, so it's not a natural number. Is it an integer? No, it's not a positive or negative whole number. Is it a rational number? Yes, 8/9 can be written as a fraction. It is a fraction, and so it is a rational number. And it is going to be a real number as well. Square root of 20. Well, first of all, what is the square root of 20? Let's see. I know that the square root of 25 is 5. I know that the square root of 16 is 4. I don't know. It's 4 point something. It's somewhere in between 4 and 5. And so I don't know what the square root of 20 is. Now, your calculator doesn't know. It can estimate, but it can't actually know. So it's not a natural number. It's not an integer. It can't be written as a fraction because we don't know what the number is. It is real, but it's an irrational number. It's like the square root of 10, the square root of 2. If we can't take the square root and get a nice number, then it is going to be an irrational number. And so when it says classify the numbers, it means give it as many names as you can. Natural, integer, rational, real, that's the most you could give it is 4. Sometimes it might just be rational or real. Sometimes it'll just be irrational. But that's how those work. And in lieu of time, ask me about complex numbers in class, please. It is very interesting about numbers that are not real. So please ask me about those in class.